Hey there, it's Modern Retro Tech, and today we're doing another Advent of Code stream. We will be doing days 5 and 6. I already did day 4, and I will just start with quickly showing what I did and how it works. So day 4, it will be just a review. I'm actually quite happy that I didn't try to do it on the stream because I think so far it was the most boring day, sorry, because it was essentially just a lot of validation stuff. But I hope the days 5 and 6 will be funnier. I haven't read the tasks there yet, so I have no clue what is coming there. But let's start without further ado with day 4 review. I will quickly go through the task itself. I won't be super detailed. I will skip the whole backstory. But in essence, you arrive at like passport control thing. And there are like different requirements for passports. And you need to your passport needs to satisfy them, but you have North Pole credentials that don't have country ID. So your passport is essentially a hash map with key values that are specified in this format. So key, then double dots, then value. And between like different passport entries, you have a blank line. So first, of course, you need to parse it, and then you need to check that passport is valid or invalid. First check is just you need to check that all those fields are present, and you need to ignore country ID thing. So for that, I essentially wrote this module. I'll make it a bit larger. So here you can see we start with parsing, then we go through the passports, vector of password things that we, oh, sorry, it's wrong day. We need day 4, of course. So yeah, but it's the same. We parse input, and then we have an iterator of a vector of hash maps of this key value things. We filter each passport with the isValid function, and this valid function just checks that we have all the required keys. So we take the list of required keys, we iterate, and we check that for all of them we can find a corresponding key in the, this actually, by the way, is passport, not password, hash map. And then we just need to count valid passports, yes. So when we, as you remember, we also have this REPL interface. So here I specify the D4 part 1s and 2 are available. So I can now do D4, and we get my answer 245 for my input, and that is the correct thing. Next thing, they essentially add a bunch of validation requirements for each of those passports, for each of those fields, sorry. So for example, all the years should be 4 digits, they should be in certain ranges. Then we have height, which can be in centimeters or inches. And then depending on that, you have also different minimum and maximum values. And then you have specific requirements for hair color, eye color, passport ID, and you still ignore country ID. So I implemented that. In essence, solve2 looks exactly like solve1. The only difference is that here I'm using isValid2 function instead of isValid. And then isValid2 function is using isValid function to check that we have all the required fields. And then it calls validators on each of the fields. So for years, I provided this function called isValidYear, which just takes this year thing, which here is a slice of string, and minimum and maximum values, and then it parses it, and if it is parsed and is between minimum and maximum, then everything is satisfied, we return true. If not, we return false. So we can use it for the first 3 fields to check that they are valid. Then we need to check valid height. For that, I just used a regex. So I extracted 2 named groups. I extracted one group that is number and another is unit. And then depending on the we parse number as U32, and then if it's okay, we check the unit. If it is something that we expect, we apply corresponding minimum and maximum constraints for each unit. One cool thing that I'm using here is lazy static. So the thing is, in Rust, you often you cannot by default create constants that require like heap allocations or some complex processing. And sometimes it can be problematic because if I will try to compile regex in each execution of this helper that I execute while iterating through a vector of elements, it will be quite slow. So instead of doing that, I'm using lazy static, and essentially the first time I call this RE thing, it will create a corresponding static value. It just injects some code, it's a macro, and here I just use it to optimize my regex usage and precompile it once when I need it, and then just use the compiled regex every time I go through that. Then I have also some validators for hair color, so that's just the regex as well, and here I just need to do a match. And for eye color, we just have a vector of values, and then I can use contains. And I'm also, by the way, using this lazy static thing to only create this vector of expected values only once, not on each element of the vector. And there is finally valid pit, which I don't even use regexes for. I just have a specific requirement for that, which I'm using. So then I, of course, did tests. I did a bunch of mistakes originally, as is expected when you write code like that. So, for example, I mixed up, I think, eye color with hair color, and then I spent like 10 minutes trying to debug it. But thankfully, there were a lot of examples, so I, in the end, found the error quite quickly. And if, for example, we execute all those tests, you can see that there are quite a bit of tests for this condition, right? So we have 7 tests here in D4. In the end, though, we can execute this as D4-2, and we get part 2 answer, which is 133 for me, and it is indeed so. So that puzzle was solved. Now, let's look at day 5. I haven't read the task before, so I will be reading it, and then we will try to figure out how to solve it. So, and by the way, for those who are joining right now, we are solving Advent of Code in Rust. It will be live coding sessions for days 5 and 6. So yeah, let's read day 5. Binary boarding. You board a plane only to discover a new problem. You dropped your boarding pass. You aren't sure which seat is yours, and all of the flight attendants are busy with the flood of people that suddenly made it through passport control. You write a quick program to use your phone's camera to scan all of the nearby boarding passes, your puzzle input. Perhaps you can find your seat through process of elimination. Instead of zones or groups, this airline uses binary space partitioning to seat people. A seat might be specified like FB, FB, BF, FR, LR, where F means front, B means back, L means left, and R means right. Front, back, left, right. Okay. The first 7 characters will either be F or B, so only like for front and back. This specifies exactly one of the 128 rows on the plane, numbered 0 through 127. Each letter tells you which half of the region the given seat is in. Start with the whole list of rows. The first letter indicates whether the seat is in the front or the back. The next letter indicates which half of the region. So it's like essentially binary splitting with each letter. The next, and so until you left with exactly one row. Okay. For example, consider just the first 7 characters of, how many characters are here? So this is like 5, 6, 7, 10. Okay. Start by comparing the whole range, rows 0 through 127. F means to take the lower half. Front. The 0 is here, 127 is there then. So front lower half, 0 through 36. B means upper half, which is, oh god, this is so confusing. I would also say back thing then, which is 32 through 63. Front lower, so 32 to 47. B upper, 40 to 47. Oh yeah, that will be fun to do the divisions here, I guess. And B 44 through 47, F 44 through 45, F row 44. So that's how you find the row, by like dividing it continuously in half. And then you guaranteed to arrive after 1, 2, 3, 4, 5, 6, 7 things to one row. Okay. The last 3 characters will be either L or R. This specify exactly one of the 8 columns of seats on the plane, numbered 0 through 7. The same process as above proceeds again, this time with only 3 steps. L means to keep the lower half, while R means to keep the upper half. For example, consider just the last 3 characters of blah blah blah, R, L, R. Start by considering the whole range from 0 to 7. R means to take the upper half, so from 4 to 7. L means to take the lower half, keeping columns 4 through 5. And the final R keeps the upper of the 2, column 5. So decoding reveals that it's a seat at row 44, column 5. Every seat also has a unique seat ID. Multiply the row by 8 and add the column. In the example, the seat has ID 44 multiplied by 8 plus 5, 357. Here are some other boarding passes, so those are our tests. As a sanity check looks through your list of boarding passes, what is the highest seat ID on a boarding pass? Okay. So and then we get our puzzle input, which is essentially those like coded things, and we need to decode them to row and column using this process, then multiply the seat ID and then take the highest seat ID from this vector. Okay, makes sense. Let's start with that, I guess. We will need a new module for that. Then we will need to quickly create an input thing here, which will be this stuff. And then we can create the module file itself. So it will be C5RS. We use the same signature for solving stuff, right? I will just for now already add everything that I know we will need, so we don't need to think about structure much. So solve 1, solve 2, and we will need a testing module. We probably will need a test for pass boarding pass decodes, I guess. And there we say we will probably need a function which will be parse decode boarding pass, which will take I will just call it pass, and then it returns us a row and column, right? So U32, U32. I will also make it an option for now, just in case, because I don't know if it will work with decoding everything. And here I return none, and here I will just say that for my boarding pass, which will be decode, yeah, we also will need to use super thing here. So for decode boarding pass, that is our test input for day 5. The first one, this one, we will need to get some row 44, column 5. So that will be our thing. What don't you like? Oh yeah, of course I need to use different parentheses here. So now I can run it, and we will see that our test of course fails because we haven't implemented yet anything. Yep, exactly. But hopefully we will fix it very quickly. Now, one last thing, I'm adding here day 5, so we can also call it from REPL. And of course, we still need to update the stuff. And here we go. So now if I call them, you can see that it returns none. So that is quite expected. Let's start with the parsing logic for this binary boarding stuff. So first, we need to verify that we got enough letters there, right? So so if we exit immediately, we don't care. I actually wonder if this will work. Like, I will just do it like that and see. Oh, okay. Now we validated the length, and we now need to specify the row and column. So, yeah, row and column selection thing. Now the thing is, the algorithm will be the same, right? We have like a range of numbers and we divide it continuously until we arrive at something that is only one value in this range with specified number of things. So we will need to have some kind of a common function there. From range, and here we will just take pass, and we will take we'll take everything until the number 8 essentially, so 0 till 0 till 7, I guess. And we will start with 0 and 127. That will be our row. And our column will be like that, I guess, from 0 to 7. And then we can specify this thing. So it will take divisions, which will be also reference to string, and min and max, so range intervals. And it returns, let's do also an option of what actually will be the division, right? We will probably return, we still will return a range, right? Yeah, seems so. So we'll have also this, and then of course here and here. Oops. We will have U32 as well. Yeah, sure. We need to make it the proper slice. So, and in the end, this thing will probably, like, this function will be, by the way, recursive, but here I think recursion is safe to use because we will have only like several iterations of it. In the end, we should arrive at a range that is the same number, right? So, okay, this will be divide range then instead. And extract from range will be a wrapper around it saying divisions string, and it will also take min and max, but it will return then actually I can even remove option here and just do this. So this thing actually will then return U32. end option. So that's how it will work. For now, we just do that to satisfy a thing. So this will be an option, this will be an option, and then we say, is it, and then option B. Okay, we need to do both, so I guess I will just do I don't know if there is a more beautiful way to do that. So if you know some more beautiful way, you can specify it in the chat. And here we have the magical thing, and anything else we say, we will just panic for simplicity, I guess. No, we just, for now, let's return none. We didn't find anything. So now we can start working on those functions. We can do extract from range. So this thing will do what? It will just call divide range with the same arguments, and then it will see if we got something that is if those are equal, then we say we return them, well, any of them, because it's the same thing. If those are different, we say actually I won't probably return result here, right? I will say error, and here I'll say okay, so that I actually got some better description. Didn't arrive at one value, right? So this will be format. Yep. I'll just call this stringly typed results. I normally will do boxed in error here, but I don't want to care too much. I just wanted for some reason to have a better error message here. So this thing, what do we do? In essence, in our task definition, we can see that we always get this lower half, upper half thing. We have different letters, but they have, now I understand this logic. It kind of has different semantics, right? We have, we can use the same thing. Essentially, F is the same as L, I guess. Yes, and B is the same as R. So start by considering the whole range, and then let's say, so divisions. I wonder how it works with pattern matching in this case. So can I do like division and then rest? I think this is called subslice patterns, I think. Yeah. Oh, and then you kind of can do this stuff. For now, I'm just doing this. I know that looks really dumb, but it doesn't like it. Divisions, chars, I guess. Oh, I know what I want to have here. I want to have reference to a slice of chars, right? So then I need to do chars and reference. And then here I don't need divisions. It doesn't like it. Char. Right. Okay, so, and then we can just essentially map it by division, right? So, we can do match division, and then depending on this probably will be like rest, or I guess it's a bit different syntax. Okay, I need to check it out again. Oh no, cannot be known. Oh, reference. I think maybe I can say ref. Yes, it works. Yeah, okay. So here with match divisions, what we will have? We have chars which can be F, or it can be L. I don't remember if the syntax actually works in Rust. I'll just do this for now because I don't want to be super complex about this. B and R. Why? Oh yeah, because it's non-exhaustive. So here we can just panic because that's stuff that we don't want to process. We guaranteed by the inputs that we won't get any new characters. So we can say unexpected division. And just do division, right? Now here, this logic, we need to change it a bit. So we have front and left lower half. So then we essentially like 127 divided by 60 divided by 2 will give us what? Gosh, this is kind of math that I really hate. I will also, again, use my trick with having Elixir interpreter to figure it out because otherwise it's a bit painful. So if I do like integer division, it will be 63 actually. Okay, makes sense. This is like, I guess then what I can do, I can pre-compute this middle point, right? Middle, which then will be max minus min divided by 2, I guess. This still will be integer, thankfully. So then, but this works with this stuff. For example, if I say 63 minus 32 gives me 31. Even if I divide it by 2, it's 15. And then 32 plus 15 will give me 47. Yeah, okay, so that makes sense. That's how we can calculate stuff. Take this essentially is the half of elements amount, right? Half of elements length. It's length of half of elements of the range we have. And then when we need to take the lower half, we essentially take min and min plus half of element's length. And if we need to take the upper half, we then take this, I think. But then that, by the way, may fail. So let's look at our last numbers. So 47 minus 40 gives us 7. 7 divided by 2 gives us 3 with integer arithmetic. So 43 44 to 47. Yes, this will work for us. And then if we try to do 47 minus 44, it's 3. We divide it by 2, it gives us 1. So then it will be 40. Oh god, this is a bit mind-breaking. 44 plus 1 will be 44, 45. Okay, makes sense. We got here now. And then if we... so if we have only 2 numbers, then we need to do a different thing, right? So if we have only one... or actually, maybe this logic will still work. So 45 minus 44, it's 1. This will be 0. So then this will be minimum and this will be maximum. Oh yeah, actually it should work without any additional special casing of this stuff. So we do this, but instead of just returning this range, we then call ourselves recursively with rest, essentially. So that should solve this, I guess. We do divide range, we do this, and then for input, we actually don't even need to do parsing this time. We just go to code binary parse input, and we get extract from range. Which gives us row and column. And then what we need to compute this will be row multiplied by 8. This is, by the way, not the answer yet because we also need to find the maximum, right? Plus column, but that will be already something, so we can see what we get. And of course, if we get none, we just return none, right? So that will be the thing. What don't you like? Oh yeah, this will be some, of course, it will be this, I guess. Row and column. But then we can here do decode boarding paths. Yes. Yeah, we say some. So what don't you like? Found. Yeah, sure. As I64. Okay. So now we can try to run our test again and see if it works. And something didn't. We got none. This is interesting. So let's first of all do debug on those. So debug and debug here. So the test still fails. Do we actually get anything? Oh. It seems that we don't even get as far here, right? Let's instead return result here. Right. So that will be one thing. And then here I can just do unwrap and then say row and call. Actually, that looks a bit better for our purposes at least. And here, of course, we then return error. Didn't arrive at one solution. And I guess row column, right? And this will be row. This will be column. And we probably will need to do debugging here. And then here we don't need it, because we will print it anyways. What don't you like? Really? Oh, already this consume them. This is interesting. Oh, actually, there is an, I guess we can do always reference. Here I can always do reference. Or am I going crazy? Okay, I will just do it simpler. I don't want to spend too much time with this stuff. I will do unwrap. And I will do unwrap. And I will get my error stuff anyways. Yeah, and then I can drop this scene completely. Just do row and column. And here then can just panic. Let's just panic. And here then I don't even need to do that. So now let's try to execute our magical test again. Oh, of course it's no longer sum, right? It's just a tuple now. Invalid length 10. Oh god. Yeah. Sure. So we do this. We need to change it to 10. And now we decoded it. So that worked. Now, and you can see we were able to generalize, and we used recursion here to do it very simply. We also used slices to avoid excessive copies. And we use subslice patterns to do this kind of pattern matching. I think it's one of my favorite recent features of Rust because it simplifies doing this kind of like functional style programming a lot. Yep. So now what we actually need to do, we need to scan our input and find the highest seed ID. So let's also extract this logic seed ID, where we take pass and we return just U32. And then we do this in essence. And then, of course, here we then do our typical things. So for input, we split, we trim and we split ASCII white space, and then for each of those, we get iterator, right? We max by. Compare, I can just do maybe then. So I can then just map, I guess, with my seed ID pass, and then I just can take a max from that. And that actually will even be an option, right? And I will just map it to make it max seed ID. I will make it into int 64. because we are unsigned here, so we need to do this. Okay. So now we can try to solve our puzzle finally. Part 1 solved. And we add our typical magic, so. And here we say input, we do read to string, and we read input stay 5. And then we just do solve on reference to input. And we expect to get, I don't know, reference or sure via unwrap. Let's run it and see what our result will be. 822. Let's try it out. Yep, we solved it. So now to part 2 of day 5. Let me quickly correct the test. Make sure that both of those pass. It works. Let's see that it also works in our magical interpreter. That is not very interpreter or useful yet. We will need to improve it for sure. And yeah, let's start with part 2. So, Dean, the fasten seatbelt sign have turned on. Time to find your seat. Oops. Let me move it up a bit. Gosh. Yeah. Signs have turned on. Time to find a fasten your seat. It's a completely full flight. It's a completely full flight, so your seat should be the only missing boarding pass in your list. However, there's a catch. Some of the seats at the very front and back of the plane don't exist on this aircraft, so they'll be missing from your list as well. Seat wasn't at the very front or back though. The seat with IDs +1 and -1 from yours will be in your list. What is the ID of your seat? Okay, I'm trying to wrap my head around it. So your seat should be the only missing boarding pass in your list. However, there's a catch. So we essentially get like a range of possible seats, right? We know that there are 127 rows and there are 8 columns. And then for each of those, we have a seat, but some seats in the very front and back don't exist on this aircraft. So like from either edge of this like rectangle. So they will be missing, but we know that our seat is not one of those, and we need to have seat with ID +1, so like the next one and the previous one will be in your list. And this is for seat ID. So then for each seat we will have like the seat ID very front. And it doesn't even specify what we get, right? Okay, let's try to do one thing first. So I will move this stuff a bit down. And what we will do here, we will take our input. We will do all this stuff. And then we will pass to string. Because I want to see how it looks. Is it like in string? I forgot how to join strings, so God. Let's check it out. Okay. I guess I need to just collect stuff, right? Join it. Let's call it all seat IDs. And then we can just... let's just print a len for now. I think it will be as a long list, but doesn't matter. Right. So now actually our interpreter will be a bit useful because we can do D5 too. And we got a list of those. So this is kind of, let's clean our screen. Let's execute it again so we can look from the beginning. So that's how it looks. I'm thinking, do we have any additional, like, do we actually need to care about this restriction about seats are very in front or back of the plan don't exist thing? Because I think yours will be in your list. So we should find, like, there is 430 and 431. So for example, if there were like 430 and 432, would it mean that that's our place, I guess? So then what we can do, we will need essentially to, we can do again the set thingy, put all those IDs in a hash set and then just go through that. And for each of the numbers we get, we can check if there is a number that is +2 or -2. And if there is, then we know that we found our seat. So let's try to generate a list of candidates then. So let's do HashSet. We will need to do collections HashSet, right? And we won't convert them to strings anymore. We'll change it here. Then what we do, we just need to do all seat IDs, find like iter, find, or like, yeah, for that. Actually, I want to run filter because I want to see how many elements I get. So I will run a filter. I will get a seat ID, right? And then I will check that. So if this is our like previous seat ID -1, that we need to find the seat ID like expected seat ID will be, for example, seat ID +1. Then we also will have +2, right? Contains seat ID +2. Oh, we can actually do even filter map, right? And then if that, we know then we need to return seat ID +1. Alternatively, all seat IDs contains seed ID -2, then we will need to return some seed ID -1, I guess. And alternatively, we return none, right? Right. I guess. So candidates and unnecessary parentheses, sure. Found, sure. Like actually I can do it like that, I guess. And here as well, unnecessary, let's add reference. Those methods like get and contains, they typically expect reference in Rust. So in this case, we have overridden definition of adding reference to some integer, or like subtracting reference of the integer with like integer and vice versa. So that works. And of course, identifier. And here then we get candidates. So let's see, because now we can again restart our stuff and do D5 part 2. And of course we need to collect. Yes, this is an iterator. Nothing happens until we collect to a vector, I guess. So we can try it again. So will be in your list. Oh. So it like filters nothing or what? Don't exist on the aircraft. Front or back zone? Yeah, we probably need to also do HashSet here. Let's do that just in case to remove duplicates as well. I'm trying to understand how it can be. Okay, that didn't change the situation much, right? We still got so many numbers, but I also really wonder. So you know what? Let's save this stuff. So I will just do right. And here I will say inputs day 5 test, and the content will be seed IDs, iter, map to string, collect to vector, join these new lines, this stuff, and then wrap, of course. So now I will just execute it, and I got this in. So we can then see what is happening here. So for example, we got 59, 59, it means that there should be places, 60 should be here. I cannot, oh yeah, 60 is here, and 58 should be here. Yep. So 639, we will have 640. Yep. And 638. Yep. So it seems that this is not sufficient to just do this kind of search, right? So you see it should be the only missing boarding pass in your list. However, Yeah. And my thing, it should not be present itself. Oh God, of course, so that's important condition as well. So apart from like seeds in front and in the back of it should be present, or like previous and next seed IDs should be present, but it itself should not be present. I will just do if all so that will be a candidate, right? And then of course we just need to do if. Not the most beautiful thing, but contains candidate. So it should not be contained. That already should, oh, okay, now I see how it will work, right? So you do this, and then we probably will need to exclude like fringe things. Actually, we can then just do like, oh no. I will just do another pass. That will be a bit simpler. So at least in terms of code, it will be a bit more beautiful. Do this and this. This I just completely remove. And here I add additional filter. So I say candidate. And oh, I don't even need to do a block here. I can just do all set IDs contains candidate not. So now we can try it again. 705. Let's see if this is our correct answer. Yay, we solved it. So like the whole thing about previous and like less thing being missing, we didn't need to care, which I think funny. We collected to HashSet, and then if candidates length, so like this stuff you also don't need, right? How it's like drop, delete. It replace reserve take, I guess. Oh, no. Subset get. This returns borrow, extend drain. Okay, we need to quickly look at that because I always forget how this method is called when you just need to take the first thing from the set, but actually take ownership. So difference contains clear capacity. Removing hash intersection is iter new replace remove. It's present in the set. Replace reserve. Shrink to take. It doesn't have like drop, I guess. Yeah, this is like borrowed thing. Drain. All elements. Oh, okay. I guess we will just need to drain then. Then do we will take only one of those, and then we will collect it into a... Can I collect it into a box, actually? Or like, take one, collect into vector, and then so slice. Oh yeah, I can do... Well, I'm always getting that I actually can just do next here, and that will return me... And then actually, that's the thing. And alternatively, we just panic more than one candidate. And here just do candidates, right? And that stuff you then can remove. What don't you like? Yeah, next. And we map it, of course, candidate as E64. And candidate should be declared as mutable. Yay. So now then, if we do... It works, and we can quickly add a test. So part 2 solved. It should get 705. This solved 2. Let's run our tests. And everything works. So I'm quickly committing it, and then we switch into day 6. I will remove day 5 test. And so let's look at day 6, I guess. Our calendar is becoming more and more beautiful. I'm really wondering what it will look like when we finished. So day 6, customs. So more flight horror continues. As the flight approaches the regional airport where you'll switch to a much larger plane, customs declaration forms are distributed to the passengers. The form asks a series of 26 yes or no questions marked A through that. All we need to do is identify the questions for which anyone in your group answers yes. Since your group is just you, this doesn't take very long. However, the person sitting next to you seems to be experiencing a language barrier and asks if you can help. For each of the people in the group, you write down the questions for which they answer yes, one per line. For example, ABC X, ABC Y, ABC Z. In this group, there are 6 questions to which anyone answered yes. A, B, C, X, Y, and Z. Duplicates answered to the same question don't count extra. Each question counts as at most once. Another group asks for your help, then another, and eventually you've collected answers from every group on the plane, your puzzle input. Each group's answers are separated by a blank line, and within each group, each person's answers are on a single line. For example, ABC, ABC, ABAC, AAAAB. This list represents answers from 5 groups. The first group contains one person who answers yes to 3 questions, A, B, and C. The second group contains, let me guess, it's 3 people. Each answered yes, A, another answers, and the third answered C, yes. Yep. And third group, 2 people. Our first answered A, B, yes, and the second answered A, C, yes. 4 people, they only answered yes to A, but all of them answered yes to A. And the last group contains one person who answered yes to only one question B. In this example, the sum of these counts is 33311. is it just like put everything into a set and then some set lengths? I guess so. For each group, count the number of questions to which anyone answered yes. What is the sum of those counts? Okay, I guess HashSet comes to our help again. So far, HashSet is the most important data structure in this advent of code, which is really nice. Let's do day 6 Rust. I really wonder if there is some catch, because that sounds very, very simple. Just for fun, let's also add the sample for the day 6 here. So yeah, we got the group stuff, and here is our sample, right? And now we can, well, we are doing all our typical rituals, right? So taking this, I think I will be writing this on like full automate with the end of our awk. I'm just trying to copy some stuff now, because so, and then we can do day 6. And just do like none here, right? And let's just also do one with the sample. Part 1 works with sample. And here really what we do use std collections HashSet. Then what do we do? We just take the input, then we say retriment. Let's do, oops, yeah, I forgot one important thing. We need to put this stuff in our main as well. So we need to declare a module, and we need to declare this stuff, update this stuff. Then we like G6, 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 G6. Okay. Now we do treatment. We then can for each of the groups we do split. We split on double new line, right? Empty blank line is new line, previous one, and the one here. So that's the each group. And then for each group, we say, what do we need to count? We just say group is, let's say, answer sets, and here, actually, do we even care? We don't even need to. Three questions. We don't even need to like split them, right? Because like we just need to count unique letters here. So for each group, but let's still do it. So say group, we split. We just, that I will do for removing new lines for now. And then for each of those, we essentially create, actually, I will even do, yeah, let's just do mutable HashSet. I think it will be even simpler. Answers. Oh, no, I'm dumb. I need to do hash map, right? Because you need to keep counts. Sure. So, and then I guess, oh, okay, I see. So we have a hash map, and for each of those, we need to just update it. So counts, we say hash map new, of course, it will be mutable. So for each group, we do for group in split. And then group will be, let's split ASCII white space, sure. And then for person in group, we actually don't do that. We can just group is reference string. Can we do group chars, then filter, so any char that is not a new line, right? For answer or like question in, that will be one char, and then we can do for question in group chars filter. And then does it has like dedup or unique? Here we actually need to collect into HashSet, right? We just collect then into HashSet. So we get like unique questions here. And then for each of those, we do entry for, this is, by the way, one of coolest things about Rust. I really like this mutable hash map interface with entry API, where you get like this special data structure, and then depending on if there is an entry for the key that you insert in or like checking, you can do different things. For example, insert default value or doing stuff like that. I think it's a very beautiful API. So here we need to say question is a character. Yes, we do character. And if it's not present, we do or insert 0. So we actually do the same thing. Count, and we just say count is, and count is, what's the, it's mutable reference, right? Then we just do this. Type muted char. Oh yeah, I need to dereference it, I'm dumb. So that should count stuff for us, and I think that's actually it. Oh yeah, we need to sum then those counts, right? But that should be, this person answered yes to 3 questions. Oh, no, I'm dumb. So for each group, we just get like, okay, I'm going a bit crazy. I'm thinking I'm overcomplicating this now. So for each group, I need to get one integer number. Yes to 3 questions. And yeah, and I was boasting how simple this task is. So we need to essentially get the count of unique letters for each of those. So collect, this is actually the thing, right? Yeah, oh god. And then I just need to return lengths. So this is group. And then actually I can write all of that as iterate, right? So for split, and then for I do in map where this is a group and this is my logic, and then I just do a sum on that, I think, right? And this will be sum of counts. And so the thing we need to say this, for example. Oh, type as subscription is maybe this. No. Well, don't you like it? Type annotation needed. Sure. If I say this, then the trained bound is not satisfied. Actually, I can just simplify my life significantly here. And here, then I don't need to convert anything. Yes, okay. So now let's see if we solved anything, right? So we got this magical number. Oh yeah, this sample, by the way, we need to get some 11, right? So to check if we did anything. Yeah, it works. So I'm pretty confident that the output from REPL is also correct. Let's try it. Yep, we solved it. Okay, that was quick. After all, that was quick part. So part 2. Yeah, let's quickly also add this thing here so that we have a test. And then when we run the stuff, okay, and hash math we actually don't need for now, so we can remove it. Now let's see the part 2. As you finish the last group's customs declaration, you notice that you misread one word in the instructions. You don't need to identify the questions to which anyone answered yes. You need to identify the questions to which everyone answered yes. Using the same example as above, this represents answers from 5 groups. In the first group, everyone, all one person answered yes to 3 questions, A, B, and C. In the second group, there is no question to which everyone answered yes, so it's like 0, I guess. In the third group, everyone answered yes to only one question, A. In the first group, everyone answered yes to only one question, A. In the fifth group, everyone answered yes to one question, B. Those counts is 3 plus 0 plus 1 plus 1 plus 1 equals 6. Everyone answered yes. Okay. So what did we, how did we do it actually? So we need to find an answer. We need to take this like all the characters, right? Like all the answer there. And then we need to make sure that each person answer there. Is there some like nicer way to do that than just going first creating a hash set and then going again through each of those and checking that they all have answered that? I'm not sure. Like in principle, this is like intersection thing, right? So, oh yeah. So like here, all of those are like if we take a hash set of A, B, C with 3 elements and we intersect it with itself, it will be ABC, right? If we take A and we intersect it with B and we intersect it with C, we get nothing. If we get AB and AC sets and we intersect them with each other, we get A. Then A sets intersect to A, and B intersects with nothing, so B. Ah, okay, so in essence, that makes sense. So we can start with the same logic. But here we will need to reconsider it a bit. So if you have a group, and for each of those chars, we create a... We will need to actually do splitting by person here, right? Group split. So this is like person. And they will, I can then say chars, and they then can collect them into a hash set. So each person in a group gets the hash set with the answers, with the questions that they answered yes. And then we need to intersect all those hash sets together. So we then need to do like fold first. So it's the same as fold. It uses the first element in the iterator as the initial value, and then it folds everything with it. So do fold first. Is it like some... Ah, it's unstable. Oh shit. Okay. Let's see if we have something stable. So where it is defined. This is not only experimental API. Well, okay, fine. This is a bit weird. But we can also actually do this fold and do that will be a bit weird. Let's maybe collect it into a vector of those hash sets. Answers per person. So then we can try to do the folding thing. So fold iter fold. So now we can just say answers per person 0, right? And then actually we can just clone it. So this is like our first person answer. We create a new hash set from that, and then we get our all yes, and we get our answers per person. Okay, like person's answers. And then we just do all yes, intersection, this person's answer. And it doesn't like something. What don't you like? Hash set intersection. Ooh, it's also in iterator. We can collect them. char. So this thing is char. Sure. This. So now we got the answers per person thing going on. We should get a intersection of all answers for each person. And that should get us all yes thingy, which will be also a hash set. And then our thing will be just all yes length. I can actually even remove this, I guess. I can just do it. One thing. It's a shame that fold first is not yet stabilized, because then our solution would have been even simpler and would have been one-liner, but okay. As I... So let's see if that solves our sample input correctly. Part 2 works with sample. Let's move it here. Oops, forgot the test attribute. Here, just do solve 2. And our answer should be 6. Yeah. Let's see if it works. Yep, seems so. And previous parts also work? Yep, they do. So let's get back to our REPL and let's try to get our answer. 3351. And we solved it. We solved day 6 as well. Let's add the test, commit everything, and I guess I will see you back on Tuesday after that. But yeah, first adding the test. Very important thing. We shouldn't forget about this. Yeah, day 6 was simpler than day 5, for me at least. But this is also because of set operations. So I think if you don't know set operations, this can be a rather tough thing to solve. So this will be this. Maybe we should also regroup it like that. And then we can execute it. Yep. Now, another thing that I want to see if, yeah, all our tests execute and run very fast. We have already 24 tests, which is pretty nice. I really wonder if this time there will be some kind of like long running thing where you have like virtual machine or something like that. But I guess we'll see. Let's just commit this stuff. So thank you very much for watching. I will see you on Tuesday at 8 p.m. Central European time. As usual, we will be doing days 7 and 8, I believe. And yeah, we will continue our Rust adventure. I think I'm getting up to speed. I also really enjoy how I'm learning a bit of like additional collection operations and stuff like that that I haven't used before while doing those tasks. So far, it is quite a pleasant journey, and as usual, every year Advent of Code is really one of the highlights. I hope you enjoyed it too. Write in comments, how do you feel about it so far? What are your impressions? Don't forget to like and subscribe, and I will see you next time.